all of your perfect squares are. Okay. So let's see, 13 times 13, that's 169. I know I have the screen frozen, I'm fixing it. 14 times 14, that's 196. 15 times 15, that's 225. 16 times 16, I think that's 256. 17 times 17, I always mess that one up. I think it's 298 or 289. 7 times 7, 289, I think. Someone check that. 17 times 17, 289. Just look at your times table. Yeah, okay. 18 times 18, 324. 19 times 19, 360. I don't know. Yeah, 361. Thank you. 20 times 20 is 400. 20 times 21, 441. There you go. That's quite a bit of them. Okay. So it means that your minus sign, you're going to have minus, and it's going to be one of these numbers. How do we know if a variable term is a perfect square? The exponent is even. X squared, x to the fourth, x to the sixth. Those are perfect square variable terms. The exponent is even. That's important. And I didn't write that on your filled out notes. So if you have a copy of filled out notes, I would write that. How do you know if the variable term is a perfect square? Because the exponent is even. The exponent is even. That's super important. So when you have dots, when you have the difference of two squares, they factor out like this. Okay, so this, I'm going to just take this x squared minus 4, and we're going to look at it. Well, I know that x squared is a perfect square because this is even, and I know that 4 is a perfect square. The square root of 4 is 2, so it was made by taking x plus 2 times x minus 2. Why? Well, when I FOIL these, 2 times x is a positive 2x. But x times negative 2 gives me a negative 2x. And what happens to the b term, the term in the middle? They cancel each other out. Yeah. These have a special name. Does anyone remember from Math 1, if you have me from Math 1, what we call these? These are called conjugates. Same number, opposite sign. It's conjugates. Okay. They're called conjugates. That'll be helpful when we start simplifying crazy stuff. Okay. So if we have two terms, both of them are perfect squares, that's going to be the difference of two squares. Okay. So let's look at a couple of examples of the difference of two squares. So let's look at our first example. M squared minus 49. Well, I know that m squared is a perfect square because my exponent is even, right? But what is the square root of 49? It's 7. So this factors to m plus 7 and m minus 7. Okay. Got it? Okay. Let's look at example number 2. Let's see. What is the square root of 4t squared? Well, the square root of 4 is 2, and the square root of t squared is t. So this factors out as 2t plus something and 2t minus something. What am I adding and subtracting to the t's? What's the square root of 25? 5. 2t plus 5, 2t minus 5. That's a minus right there. Kind of smushed up right against that t. I don't know if you guys can see it. Okay. So these always factor as plus and minus. Plus and minus. They're called conjugates. Exact same numbers, just opposite signs. Let's look at number 3. What's the square root of 64? 8. What's the square root of m squared? Sorry, m to the fourth. M to the second. Yeah, you just divide it by 2. Okay, so 8m squared is the first term for both. I'm going to do a plus on one, a minus on the other. What's the square root of 9? What's the square root of p to the 6th? P cubed. You're right. You just divide it in half. 3p cubed. It's exactly correct. 8m squared plus 3p cubed, 8m squared minus 3p cubed. What about number 4? 13. R. Good job. So I have 13r plus something and 13r minus something. 256. 16. Yeah. Okay. Do you guys feel good about that? Okay. Feel excellent about those? Exquisite. I love that. Okay. So the next type of special case that we're going to talk about is a perfect square trinomial. And that represents itself as a binomial, like x plus 3 times itself, x plus 3. Well, we actually can write this as x plus 3, the quantity squared, which should look a lot like what you guys saw when we were doing vertex form, right? We just took a binomial and we squared it. So how do we know what that trinomial looks like? Well, I'm going to FOIL it out. What is x times x? X squared. What is x times 3x? Sorry, x times 3. And 3 times x? 3x. And 3 times 3 is 9. So when I take this x plus 3, the quantity, and I square it, I actually end up with x squared plus 6x plus 9. So let's just take a look and see if we can recognize a pattern. So if you think of this binomial as ax plus b, the quantity squared, just think of it like that, okay? How did I get the first term? How did I get this first term? Well, I just took ax and I squared it. Okay. How did I get the last term? Well, I just took the b term and I squared that. It's this middle term that always like throws everybody off. It's the middle term that always throws everybody off. But the middle term is just 2 times a x times b. It's 2 times the a term times the b term with an x thrown on it. 2abx or 2ax times b. So we're going to use that pattern. We're going to use this idea. And I'm going to kind of like make it just real basic. I'm going to just try and make it real basic. So here's what it is. The middle term is 2 times the square root of the x squared term times the square root of the b squared term, or the last term. Okay, that's really what's happening in the middle. So when you have that pattern, those are perfect square trinomials. If they're all plus, that means that the middle is joined by a plus. If there's a minus in there at all, then that means that those two terms are joined by a subtraction sign. So let's look at this first example. What is the square root of x squared? X. What is the square root of 9? 3, and it's positive. Okay. If I were to take 2 times the first term times the second term, what do I get? I'm multiplying. What is 2x times 3? Is that what my middle term is? That's how I know that this is a perfect square trinomial, and I just square it. So let me show you again what I did. Because remember I said that that middle term, this guy right here, b, comes from taking 2 times the first term times the second term. 2 times x times 3 is 6x. That's how you recognize that pattern. So square root of x squared is x. Square root of 49 is 7. Okay, let's check and see if this is a perfect square trinomial. Take that middle term, and I say 2 times the first term times the second term. What is 2x times 7? Is it 14x? Then that means this is a perfect square trinomial, and I square it. x plus 7, the quantity squared. Colt, you with me? Because it looks like you're napping. Colt, pick your head up. Shh. For the last one, shh. Say again. What is the square root of 9? What is the square root of 9? 3. It's 2x plus 3. Let's see. I take 2 times my first term, which is 2x, times my last term, which is 3, and that should equal the middle term. What is 2 times 2x times 3? 12x. Look at that. That's a perfect square trinomial. Let's look at the last one. What is 9x squared, the square root of that? What's the square root of 9 and the square root of x squared? So 3x. What's the square root of 16? Okay, so let's see if the square root of 16 is 4. Square root of 16 is 4. So let's see if this follows the pattern. 2 times the first term, 3x, times the second term, 4. Let's see, 2 times 3 is 6. 6 times 4 is, it works. This is a perfect square trinomial. So you just square the quantity. Do you see how that works? Okay. You have to make sure you check it, okay? Because it's not, like you got to check and verify that it's a perfect square trinomial. Don't just assume that it is. You got to verify it. You what? Okay, we're going to keep going. So next, zero product property says if the product of two factors is 0, then at least one of the factors is equal to 0. So how do we check that? Well, first thing we do is pull out all the terms to one side of the equal sign. Make sure that we put it in descending order, which is also called standard what? Yeah, this is also called standard form. You just want it to be in standard form. Factor completely. Look for a GCF. Look for a GCF. Okay? Set each factor equal to 0 and solve. So here's our first example. How many terms does this have? It has 2. This has 2 terms, right? 2 terms. So if it has 2 terms, that means it's probably a dots. It's probably a dots, right? So that means that this is probably the difference of 2 squares. What is the square root of x squared? X. What is the square root of 25? 5. What do I put in the middle of each one of these binomials? One gets a plus and one gets a minus. Equals 0. This means that either x plus 5 equals 0 or x minus 5 equals 0. So if x plus 5 equals 0, what is x? No, it does not. Subtract 5 from both sides and you find out that it's negative 5. Okay? If x plus 5 equals 0, guys, open your eyes. Come on, you're getting sleepy on me. X equals positive 5. These are your 2 solutions. They're opposite of the factor. The root or the solution is opposite of the factor. Okay, example number 10. How many terms do I have? 2 terms. That means that this is probably a dots. Are they both perfect squares? 36x squared is a perfect square, and so is 49. What's the square root of 36x squared? 6x. What's the square root of 49? So what's going to go in between the 2 parentheses? Like what term goes 6x blank 7, 6x blank 7? One gets a plus, one gets a minus. Equals 0. So that means that 6x plus 7 equals 0. I subtract 7 from both sides. 6x equals negative 7. Divide both sides by 6, and I find out that, no, that is not true, that x equals negative 7 over 6. So do you guys notice how these are the exact same numbers on both sides? So the second one, 6x minus 7 equals 0. I add 7 to both sides. That gives me 6x equals a positive 7. Divide both sides by 6, and I find out that x equals a positive 7 over 6. These are my 2 roots. Those are my 2 roots. Same number. They're just opposite signs. Are you guys seeing that? Same number, opposite signs. Do I need to start calling people out to have them stand up? You guys need to pick your eyes open, get them open. No, it's not embarrassing me. I love it that you volunteer. Okay, how many terms does this have? This has 3 terms. So we need to see if this is a perfect square. Let's check and see if it's a perfect square. X squared is a perfect square. Okay, what about 25? Square root of 25 is 5. Okay, let's see. 10x, the middle term, better be equal to 2 times the first term of my binomial times the second term of my binomial. Is that true? Does 10x equal 2 times x times 5? It does. So that means I'm just going to put a happy little square outside of that. Equals 0. So do I have to check both of these? Do I have to say that x plus 5 equals 0 or x plus 5 equals 0? Do I have to do that? No. I only need to check. I mean, it's the same exact thing, right? So what is x? X is just negative 5. X is just negative 5. On a graph, that's going to be a bounce. We had something like that on our test, right? We had something like this on our test. That's what that looks like on a graph. It just bounces at negative 5 on the x-axis. Okay? Does that make sense? Because I think that the graph helps you understand it. What about number 12? What are they? Perfect squares. What is the square root of 4x squared? It's 2x. What is the square root of 81? No. What is the square root of 81? 9. Remember I said if there's a negative in here at all, that means that these are joined by a minus. So let's check and see if it really is a perfect square trinomial. 2 times the first term times the second term. What is 2 times 2x? 4x. 4x times negative 9 is negative 36. So this is, in fact, a perfect square trinomial. So I just put a 2 outside of that, equals 0. Well, what does that really mean? It just means that 2x minus 9 equals 0. Sorry, it just didn't write. Add 9 to both sides. 2x equals 9. Divide by 2. Yep, x equals 9 halves. Okay, that's another bounce. That is just an example of another bounce. I'm ready to go to page 13 when you guys are. I'm going to hold up. This is page 12. I'm going to write that down here in the corner. This was page 12. Oh, this is page 13 that we just finished? Yeah, that we're going to. Yeah. Is everybody ready to go? Raise your hand if you need more time on this. Okay. So this right here is page 13. This factor completely. This is page 13. Okay. So number 1, you have to take out a GCF. If it has 2 terms, what does that mean? Difference. Yes, it's a difference of 2 squares. If it has 3 terms, that means it's either a perfect square or you have to use the AC method. It's a perfect square or you have to use the AC method. If it has 4 terms, what does that mean? What method do we use to factor it? Yeah, you factor 4 terms by grouping. Okay. These factor completely ones are tough because typically once you get it factored, one of your factors usually ends up being a dots, which means you could factor it again. So you might have something like x plus 2 and then a dots in here like x squared minus 4, which means you can factor that again. So that's why these are tricky. Okay. So let's look at our first one. Step number 1. Is there a GCF? Yeah, 8. That means I'm going to divide both of these by 8. So when I take an 8 out, I'm left with x squared minus 9. Okay, so I took an 8 out, but notice, what do I have inside of that parenthesis? Yeah, this is a dot, 2 terms. So how am I going to factor the x squared minus 9? Yeah, it's going to be x plus 3 and x minus 3. So this is factored completely. This is factored completely. Remember that once you pull out a GCF, you gotta still like drag it along with you, okay? You can't just drop it off like, you don't like it. Sir.
I'm looking at example 16 and it's very scary.
It's not scary. You'll be fine. Let's look at example 14. Example 14. Do you see a GCF? Yeah, your GCF is 5. That means everything can be divided by 5. So when I pull a 5 out, I'm left with x squared minus 10x plus 25. I have 3 terms. What does that look like? Yeah, that looks like a perfect square trinomial. Let's see. What is the square root of 25? It's going to have a plus or minus in it. It's going to be minus x minus 5. So I have 5 up front, x minus 5, the quantity squared. I want to check it and make sure that this works, right? So my middle term is negative 10x, and that should equal 2 times the first term, which is x, times the second term, which is negative 5. What is 2x times negative 5? Negative 10x. That's how I know that this is a perfect square trinomial. Okay. That's how we know that that is a perfect square trinomial. Got to look for GCFs. I think sometimes you look at something and you think it's not factorable, but it's because you've got a weird GCF in there that's throwing you off. Okay. Number 15. Number 15. How many terms are there? When I have 4 terms, what does that mean? Yeah, we got to factor this by grouping. Is there a GCF in here? Is there? Before I try to factor it by grouping, is there a GCF? No, there's not. Yeah, 1. So let's see. Let's group these. So what can I take out of my first grouping? I can take out an x squared. So when I pull out my x squared, I'm left with 2x plus 1. What can I pull out of my second grouping? A negative 9. Good job. And when I pull out that negative 9, let's see, negative 18x divided by negative 9 leaves me with a positive 2x. Negative 9 divided by negative 9 is a positive 1. So factor this. What are the 2 factors I have right now? What's my copycat? 2x plus 1. And then x squared minus 9. But I'm hearing someone say, hey, that's a dots. So how does that x squared minus 9 factor? So the 2x plus 1 does not change. It comes along for the ride, 2x plus 1. But this gets broken down into x plus 3 times x minus 3. Why do you think this one has 3 factors? No. It was a good guess. What is the degree of your polynomial? Yeah. This has 3 factors, and your polynomial is degree 3. Do you guys see that? That's important. That is important. Okay. Number 16, I'll make this plus 2 extra credit if you factor it completely. You have to factor completely, and you have to show all of your work, okay? Whoops, the T's right here. So why am I letting you get 2 points